Problem 1.1 is we need to determine how many electrons does each of the following elements have in an outermost electron shell. As answered, potassium have only one electron, calcium have 2 electrons, and aluminum also have 3 electrons. Potassium only have 1 electron because it is a very reactive and searches out other elements to make a compound. Calcium have 2 electrons because it is also very reactive element and gives up electrons in chemical reactions. And lastly, aluminum because it lies in 3 groups that has 3 valence of electrons. Problem 1.2 is to give the ground state configuration of each element that follows. Boron's ground state configuration is 1:2:2p because boron have 5 electrons. Phosphorus and ground state is 1:2:2p6 3:3p2 because phosphorus have 15 electrons. Oxygen is 1:2:2p4 because it has 8 electrons, and for argon is 1:2:2p6 3p6 also because it have 18 electrons.
Problem 1.6 is to write the electron dot and line bond of the following elements. For letter A, CHCI or chloroform consists of a single carbon atom, a single hydrogen atom, and 3 chlorine atoms. Carbon acts as the central atom in its most stable and forms 4 covalent bonds with the atom and the 3 chlorine atoms. Due to the presence of 4 electrons, domains, and its steric number being 4, the hybridization of CHCI3 is given by sp3, CHCI3, a tetrahedral molecular structure and has bond angles of 109.5 degrees. Letter B is H2S, also known as hydrogen sulfide. The representation is displayed using dots and lines that represent electrons. Dots represent the electrons that do not participate in the bond form, whereas the lines represent the bonds in the compound. In this compound, both the hydrogen atoms require 1 electron to make the covalent bond with sulfur. Sulfur needs 8 electrons to fulfill the octet rule, but hydrogen only requires a single electron to become stable as it belongs to group 1 elements. And lastly, for letter C, methylamine or CH3 and H2. The lone pair of nitrogen and the electron regions on the hydrogen atoms will repel each other, resulting bond angles of 108.9 degrees near the nitrogen atom. The carbon atom will form a tetrahedral shape and resulting with 109.5 degree bond angles. Single bonds are formed between the nitrogen, carbon, and surrounding hydrogen atoms. So why can't an organic molecule have the formula C2H7? Carbon has 4 valence electrons. One of these valence electrons is used to form the carbon-carbon single bond. This means that every atom of carbon has now 3 valence electrons left. These 3 valence electrons per carbon atom will now be utilized by hydrogen. Therefore, an organic molecule can only have the formula C2H6 but not C2H7.
For the problem 1.16, it is to identify which element is more electronegative. H is more electronegative than Li. H has 2.1 electronegative, while Li has only 1.0. Next is B and Br. Br is more electronegative than Be. Br has 2.8 electronegative, while Be has 1.6 electronegative. And lastly is Ci and I. Ci is more electronegative than I. Ci has 3.0 electronegative, while I has 2.5 electronegative.
To determine if the bonds are partially negative or partially positive, we have to remember that if an atom with a lesser electronegativity value will have a partially positive charge. And as for an atom that has greater electronegativity, the value will have a partially negative charge. So for our answers, C for carbon, Mg for magnesium, H for hydrogen are all partially positive because they have less value of electronegativity. And for N, nitrogen, and F for fluorine are partially negative because they have greater values of electronegativity. For letter D, they are partially positive and negative because they have the same value of electronegativity.
In problem 1.18, the task is to order the elements according to its iconic character. To know the arrangement of the elements, first is we need to subtract the two elements by At's electronegativity, that is why Ci20 is in the last space because it has 0.5 electronegative. Next to Ci20 is Cc14, which also have a 0.5 electronegative, followed by TiC13 having 1.5 electronegative, and lastly is MgCi2 have 1.8 electronegative.